This is the review video for the Topic 3 Part 2 test. So number 1 gives us some information about people who have registered for certain games at a club, and then asks us some questions from different topics. So Part A is a Topic 4 question. It's a chi-squared. So number 1, or I, asks us to write the null and alternative hypothesis. So null is always independent. So their null hypothesis is that game choice is independent of gender. An alternative is game choice is dependent on gender. Double I asks us for the degrees of freedom. So that's the number of rows minus 1 times the number of columns minus 1. So 1 times 2 is 2. 3 asks us for the expected value of females who play darts. So you multiply the row total, which is 52 females, times the column total, which is 25 people playing darts, divided by the total of all the people, which is 115. So you end up with 11.3 to 3 significant figures. Part 4 asks us for the chi-squared using our graphing calculator. So you use a matrix to enter that data into your graphing calculator and then do a chi-squared test. And you end up with your chi-squared to 3 significant figures is 7.79. Part 5 asks us for at 5%, would you accept or reject the null hypothesis? So when I found my chi-squared, I also found my p-value to be 0.020, which is less than 0.05, so we're going to reject our null hypothesis. Game choice is in fact dependent on gender. Part B is a topic 3 question, it's probability. So part 1 asks us for the probability that we select somebody who's a female who chose either billiards or snookers. So OR is add, so we want females who chose billiards plus females who chose snooker. So that's 21 out of 115 for the females who chose billiards and 14 out of 115 for the females who chose snooker. So that's 35 out of 115 or 7 out of 23 chance to choose one of those two girls. Part 2 asks for the probability that basically male or female means you choose somebody who plays darts or snooker. So the total number of people who play darts plus the total number of people who play snooker for your probability. So 25 out of 115 for people who play darts plus 30 out of 115 for people who play snooker. So 55 out of 115 or 11 out of 23 chance to choose someone who plays one of those two games. The last part says the probability of choosing a female given they play darts. So there's 2 ways to look at it. You can just ignore the other 2 games altogether and just look at the darts and then the probability that you choose a female out of those darts. Or it's the probability of the and divided by the probability of the second one, the given. So the probability that you are female and play darts is 17 out of 115, and the probability that you play darts is 25 out of 115. So the denominators cancel, and you end up with a 17 out of 25 chance to choose a female given that they play darts. So number 2 gives us a Venn diagram of students who own iPhones or iPads, and then asks us questions about it. So question number 1 asks for how many students there were total surveyed. That's the same thing as asking the number in the universal set. So if you just add up all the parts that you give us, we find that there's 82 total students surveyed. Part B asks us for probability of, for number 1, both students own an iPad. So we're going to assume that after you take the first student out, you don't replace them because you can't pick the same student twice, which means this is a dependent probability. It's an and it's going to, the first thing affects your second thing. So there are 35 students total with an iPad, 17 plus the 18 that have both, out of 82. So the first one you pick, there's a 35 out of 82 chance that you pick someone with an iPad. Once you've picked that first person, 1 iPad's already gone, and 1 person total's already gone. So the next time you pick somebody, there's a 34 out of 81 chance that they also have an iPad, because 1 person with an iPad's already gone if you've already picked them. So you multiply these together, you end up with 1,190 out of 6,642 chance, which if you plug that in your calculator, it's about a 17.9% chance that this would happen. Number 2 asks for both students own iPhones given that they own iPads. So you could do the probability of the and divided by the probability of the both have iPads. I did it where I just looked at the students that have iPads and I ignored the other students total. So there's 35 total students with iPads and 18 of them also have iPhones. So the chance of pulling, if I know they have an iPad, the chance that I pull someone with an iPhone is 18 out of 35 for the first person. The second person, I've already picked somebody with an iPhone, so one iPhone and one person total are gone. So the chance that I pick another person with an iPhone is 17 out of 34. So I'm going to multiply those together. The chance that I pick two people with iPhones, given that I know they have iPads, is 306 out of 1,190, which is about 25.7%. Last one, both students own iPhones given that they do not own iPads. So I'm going to ignore anybody with an iPad, and there are 32 plus 15, so there's 47 people who do not own an iPad. So 32 of those 47 do own an iPhone. So the probability the first person I pick has an iPhone but does not have, given that they don't have an iPad, is 32 out of 47. Once they're out, I have one less iPhone and one less person total. So the probability that the next person I pick is 31 out of 46 that they have an iPhone given that they do not have an iPad. So it's 992 over 2,162, which is a 45.9% chance. Number 3 gives us a truth table to complete filling out. So this is the completed truth table right here. So they gave us these first 4 columns, and then not P just means change all the truth values of P, so it becomes false, false, true, true. Then we want P or Q, which is this column here, and not P. So we're looking at these 2 columns here. And means they both have to be true for the and to be true. As soon as I see a false, the and's going to be false. So these 2 have a false, this is a false. These are both true, so our and is true. I have a false here, so the last one is false. And then the last column wants this column implying Q. So for a implication to be false, it has to be a true implies a false. Anything else is true. So if it's false implies, it's automatically true. So these 3 are going to be automatically true because you're starting out with your lie to start with. And then we have a true implying a true, which is also a truth. Part B asks us for a word that describes that argument of that last column, P or Q, and not P implies Q. And it's a tautology because all of these in the last column are true. So number 4, they give us a Venn diagram and ask us some questions about it. So part A, number 1, they asked us how many would be in that section that they label A. So we know there's 10 people total who study math, and we already have 6 people listed here studying math, so that means that 4 go in this last little bit. And for part 2, those are the students who study math, but not either science or history. And then part 3, we want to know how many students study none of the subjects. So we know there was 20 students total surveyed. So then if we subtract all the ones that we already are counted for, we end up with 2 students who do not study science, history, or math. Part B wants to know the number of students in science or history. So add up anything in the science circle and the history circle, and you end up with 14 students study one or the other or both. Part C, number 1 wants the probability, if you're picking 2 students out of a hat, what's the probability that the student takes all 3 subjects? So there's 2 students that take all 3 subjects out of 20 total students. So you end up with 2 out of 20 or 1 out of 10. And for part 2, we want the probability that they study either history or science. So there are 14 students that we just found up here that study history or science out of 20. So you get 14 out of 20 or 7 out of 10. Part D, you're picking 2 students now. For number 1, they want to know that the first student studies all 3 subjects and the other student does not study any of the subjects. So again, this is dependent. What happens on the first one affects what happens on the second one. So the probability that the first student studies all 3 subjects, there's 2 out of 20 total. After you've taken that one student out, there's now 19 left, but 2 of them still study nothing because all 3 subjects doesn't affect the no subjects. So you get 2 out of 20, and then the probability that the next student doesn't study anything is 2 out of 19. So you get 4 out of 380, or if you simplify that, 1 out of 95 chance. The next one is the probability that one of the students studies only science and one of the students study only history. For this one, order doesn't matter. So you could have a science and then history, or history and then science. So you basically double your chances of this happening. So the probability that the first student studies only science is 4 out of 20, and then the probability that the next student studies only history is 3 out of 19. Or you could flip that. The probability that the first student studies only history is 3 out of 20, and the probability that the next student studies only science is 4 out of 19. So you end up with 24 out of 380, or 6 out of 95. The last one says the probability that the second student studies history, given that the first student studies both history and math. So again, there's two ways you can do it. You can find the probability of the and divide the probability of the given. Or you can say, okay, if one student's taken out that studies history and math, that means there's 8 students left that study history. Originally there was 9. There's 8 students left that study history and only 19 students total. So there's an 8 out of 19 chance that that second student studies history, given that the first student studies both history and math. So number 5 gives us this tree diagram and wants us to finish filling it out. So remember, every branch has to add up to 100, so that's why you have 0.6 for type A and 0.4 for type B. Given that it's a type A, there's a 0.1 chance that it's faulty, and that means there's a 0.9 chance that it's not faulty, since there's only 2 choices. And then they tell us that the probability that a type B calculator is faulty is 0.12, so we fill that in here. And then therefore the probability that it's not faulty is 0.88, 1 minus 0.12. B wants to know the probability that for number 1, it is a type A calculator that is faulty. So that's an and, so you're going to multiply the probability that it's type A is 0.6. The probability given that it's type A that it's faulty is 0.1. So 0.6 times 0.1, there's a 0.06 chance that it is a type A and faulty. For number 2, we want to know that it's not faulty, or the probability that it's not faulty. There's 2 ways that could happen. It could be type A and not faulty, or type B and not faulty, so I'm going to add those 2 together. So the probability of being type A is 0.6 times the probability of that calculator being not faulty is 0.9, plus the probability that it's type B is 0.4 times the probability of that being not faulty is 0.88. Add all that together and you end up with 0.892 chance that you have a not faulty calculator. So number 6 is the topic 1 question. They give us 3.7 times 16.2 squared minus 500, and they want to know some rounding and estimation for it. So first I plugged that in my calculator and I found the exact value is 471.028. So then part A, they want us to round that to 2 decimal places. So this is an 8, so it rounds up to 471.03. Part B1 wants us to round to 3 significant figures. Since this is a 0, they just cut off and you get 471. And then part B wants us to write that in scientific notation or standard form. So you have to have something between 1 and 9 here. So a 4, that means 0.71, and we moved our decimal place over 2. So the last one, number 7, is a topic 2 question talking about some statistics. So part A, or they give us a list of 10 numbers and tell us that the mean is 5.5, and part A wants us to find this unknown value A. So the mean means you add them all up and divide by how many there are. So I added them all up and divided by 10 because there was 10 total and set that equal to 5.5. Multiply both sides by 10 and combine like terms, you get 50 plus A is equal to 55, which means A is equal to 5. Part B wants us to find the median, so I wrote them out in numerical order and found the middle number. Since there's an even number, you take the average of the 2 on the outside of the middle, and you get 5 plus 5 over 2, which is just 5. So the median is 5. Part C wants us to find the interquartile range. So the interquartile range is Q3 minus Q1. Q1 is the median of the first half of the numbers. So if I ignore the second half of the numbers over here and then take the median again, you get 3. 3 is in the middle. Q3 is the median of the top half of the numbers. So again, ignore the bottom half, and the middle number up on the top is 8. So the IQR is Q3 minus Q1, which is 8 minus 3, which is 5. So this is the review video for the topic 3 part 2 test.